Okay, so here we are for data sufficiency number 131. This is a new question from the 2016 official guide to the GMAT. And they give you this geometrical setup. It's a semicircle with a triangle inscribed in the semicircle. Now, they give you that this is A, that this part is B, that this part up here, up and down, is 2, and they give you this right angle on the bottom. So if you know this right angle on the bottom, obviously you know there's another right angle over here to form 180. What they don't give you is this right angle here. This is actually a fact that you need to know, which is that all triangles inscribed in semicircles are 90 degrees. And it's a fun fact. No matter what kind of triangle you make, as long as it starts at one end of the semicircle and ends at the other end of the semicircle, it's always going to form a 90-degree angle. Believe it or not, it doesn't always look like it, but it is in fact true. Okay, and the question for this data sufficiency is what is PR? You want to try to solve for this length PR here. So in other words, you're trying to find the diameter of this semicircle. Okay, so the first thing they give you for number 1 is that A is equal to 4. So that just this part A is equal to 4, right? Now, a lot of you might say, well, that's not sufficient, right? Because if you know only A, then it appears that you can only solve for the hypotenuse of this triangle here. By the way, obviously, there's 3 triangles here. There's this medium triangle, there's the small triangle adjacent, and then there's the large triangle, which is the whole thing inscribed in the semicircle. But anyway, if you know A, it appears that you can only solve for this hypotenuse of the medium triangle, which does not appear to be related to PR, right? But the thing is, you kind of need to think this whole thing through before you begin. You need to conclude all of the things that are possible to conclude based upon Pythagorean theorem, for example. So let's take a look at it here. So if I know that this is 2, that the height is 2, and that the width here is A, then I can't solve for this hypotenuse, but I can solve for it in terms of A, right? So I can get some A expression for this hypotenuse. And then the same goes for the small right triangle. If I know the height is 2 and the width is B, then I can use Pythagorean theorem and I can solve in terms of B for this hypotenuse, the hypotenuse of the small triangle. Now, of course, the hypotenuse of the small triangle is also the base of the large triangle, right? So this is the base of the large triangle. This is the height of the large triangle. Now I have the height in terms of A. I have the base in terms of B, which means I can get the hypotenuse in terms of A and B, right? Now, of course, A and B are 2 variables, which is why I can't solve the question yet, which you never can solve the question until you've gotten, you know, your number 1 and your number 2, right? But just keep that in mind. And so really all we have here is we have a situation where we have 2 variables and we need to get it down to 1, right? So what's our first situation here? Well, okay, it tells us that A equals 4. Well, obviously, if A equals 4 and we have it down, and we know PR in terms of A and B, then we can substitute A and then solve for B. Then we'll have both A and B, so we can add them together to get PR. So that is, in fact, sufficient. And then number 2 tells us that B is equal to 1. Well, it's the same thing. If we know B, then we can solve for A. And then if we have A and B, then it is sufficient to solve for PR. So both conditions number 1 and conditions number 2 work individually. So the answer to this very tricky question is D.